All right, here we go. So you got that little sheet here. This is the one that you need to have out. We're going to talk about matter real quick. So I am going to go and share my screen. So hopefully this will work. Present now. My entire screen, yes. Bloop. Share. Okay. Maybe this will work. Done. All right. So on that sheet, we started talking about classifications of matter yesterday. Now, here's what we're going to do, though, real quick. We're going to look at some matter here, maybe, if I have enough cups. Yeah. So I'm going to take these glasses and I'm going to fill them up a little bit with water, and then we're going to try to run a little demo. So we're going to try to separate a mixture is what we're going to try to do today, and then we'll come back and talk about how this worked, okay? So actually, Dale, would you go get me like a half a glass of water in each one of those? There you go. You lost your hand. And all of those sinks work. If you'll fill them up about halfway full of each. Okay. And in the meantime, though, we know that matter can be classified as either a pure substance or a mixture, right? Did we get this part written down yesterday? Okay. Pure substances have a constant composition. A mixture is made of two or more substances. Okay. We also know that pure substances can be elements or compounds. Elements or compounds. All right. And on your sheet there, elements and compounds we know can be broken down into either elemental helium or compounds where you're going to have more than one kind of atom. Okay, you would have more than one capital letter is the main thing you're looking at. You would have like two or more capital letters. So, for example, if you had NaCl, that's a compound, right? It's table salt. All right. If you had CO2, carbon dioxide, CO2, that's a good example of a compound. These can not be separated by any kind of easy physical process, all right? And so you've got your pure substance here. You would write elements and compounds right there. And just know elements, you could even put like a little arrow down here. An element would be helium or like oxygen gas, O2, nitrogen gas, N2. All of those are elements. And then you can just bring those up here. Thank you. All right, great. Awesome. You sit that right there. Okay. All right. So we've got our 3 glasses of water here. All right. So with these cups of water, I'm going to go ahead and put some color in there. I'm going to take some red, put it in this one. It's a lot of red. Give it a little stir. Okay. And so what you're looking at here is a mixture, right? We know that because we just saw it get mixed together, right? And then I'm going to take this one and I'm going to put some, I'll do blue and red. Which of course should make what? Purple. Yeah. Got a little purple mixture going on there. Like Kool-Aid. Super thirsty. Okay, and then just for kicks, let's mix some weirdo colors together. You want to? So we could do yellow and what else? What do you think? Blue, yellow and blue, just to see. Okay. Because yellow and blue should make what? Yes. You guys are smart. Ooh, yeah. Holy. Easter egg green right there. So you can see that Easter egg green. All right. So we got that. And so what we're going to do next, so these two have been running all day. This one has been running since first hour. This one's been running since third hour. Now, Miss Schaefer was doing this experiment because she was trying to show water properties. And if you took biology last year with anybody, water properties could include stuff like cohesion and adhesion, right? So if you talk about water being cohesive, what does that mean exactly if water is cohesive? Let me remind you, Chromebooks and phones should be put away at this point. Completely put away. Okay? Just don't want to see your phones out. All right. Now, if you talk about water being cohesive, just like I have coworkers at school, if water is cohesive, what does that mean? Together. They work together, right? Cohesion means that water molecules will pull together to get to wherever they need to go, or they'll pull together so like little water bugs can walk on top of waters because the water kind of pulls together and makes like a screen. All right, adhesion though means that water molecules can adhere to other things. So for instance, if you have like a paper towel, which I happen to have, okay, I'm going to roll this up. And what we're going to do, what we're talking about today, though, is if this is a mixture, I'm going to try to separate the mixture. Okay, I want to see if I can separate it into either just water and color or separate the colors that are in there. Okay, so I'm going to put that in there, and then I'm going to put another cup close to it. Like this. Hopefully it will like if it starts to collect the water, it'll just go in there. Okay. I'm going to do the same thing here. Another paper towel. This one. And then I'm going to do one more for this one. Now, if you're sitting up here in the first row, you can already see what's going on with the purple one. It's starting to suck up water into the paper towel. Okay. Show that over here. So if you can see that, it's already starting to suck that water up. It's absorbing. The water molecules are kind of like inching their way up there because water molecules have that ability. It's one of their characteristics. All right, and then I'm going to take this one, put that right there. And this is my green. Okay. Just for kicks, we'll do one more. All right. Okay, so we're going to let that rest a little bit. So she was talking about water properties. We're going to use this for something else, though. We'll talk about that here in just a minute. All right, so let's go here. Share screen. All right. So what we would do like on a test or something, if we had a quiz over this stuff, I would give you either some pictures or I would give you some names or symbols of stuff. And I would say, okay, which ones of these are elements and which ones are compounds? Now remember, both of these are considered pure substances, which means they have a constant composition. regardless of whether you took a little bit of it or a whole lot of it, it would be made of the same stuff. It has a constant composition. All right. So examples of pure substances would be like sugar. Now, if I ask you though, with the sugar, that C12H22O11, if that is an element or a compound, what would you say? Compound, right? It's a compound because the main thing you could know is, well, there's more than one element listed there. There's multiple capital letters. Okay, there's a capital C, a capital H, capital O. If you see multiple capital letters together, it's a compound. All right. How about gold, AU? Element or compound? Element. Very good. How about salt, NaCl? Compound, right? Good. How about chlorine, Cl? Element. Okay. And here's alcohol, C3H7OH. Compound. Good. All right. Iodine, element, right? Water, H2O, compound. Good. And on and on and on. You could do this all day. The main thing that you're looking for is in a compound, you're going to see more than one capital letter. Okay. These cannot be separated by any physical process. And if you're trying to write that on your paper, you could just write it underneath. I didn't box this very well. But anyways, you could just write it right underneath those other boxes. Cannot be separated by any physical processes. Pure substances cannot be separated by any physical processes. All right? You cannot separate elements and compounds by doing something simple to it, like just boiling it or filtering it or trying to distill it or anything like that. You cannot separate this stuff unless you do something to it like a chemical reaction. So pure substances cannot be separated by any physical processes. All right, so while we're here though, let's skip on over. Look at the middle of your page where it says mixtures. Now in that box, we said yesterday that mixtures is just where you have two or more substances combined. Two or more substances combined, right? Right? And there are two types of mixtures. There are heterogeneous mixtures and homogeneous mixtures. Heterogeneous and homogeneous. Heterogeneous and homogeneous. Heterogeneous mixtures are going to be those that you can see visible differences. So in the box for the heterogeneous, you can see visible differences. So you write heterogeneous, you can see visible differences in heterogeneous mixtures. And then the other kind of mixture is homogeneous, which homogeneous just means that it looks visibly the same. It's visibly the same throughout. They look the same throughout. And right under where you wrote homogeneous, Sebastian, you want to go stand up? I want to wake him up. Anybody? You want to go stand in the lab? It might be better. And if you can find a clean spot, good luck. So, all right, yeah, just go stretch your legs. Homogeneous, another name for homogeneous, these are called solutions. These are called solutions. Right? Solutions. All right, you can't see a visible difference. These right here are good examples of homogeneous mixtures. They're solutions. You cannot tell a visible difference. Yes, it's a different color, but you can't see like chunks of stuff floating around in it, right? This is not considered a heterogeneous mixture. It's a homogeneous mixture or a solution, okay? So what we want to do then, and by the way, when we're talking about mixtures, So we have examples of heterogeneous, and that could be like anything you can see a difference in. Soda with ice, pizza, chocolate chip cookies. If you had a big, and you're welcome to take notes back there, I don't care. But if you had a big bucket of coins, quarters, nickels, dimes, pennies, that's a heterogeneous mixture, okay? If you have a homogeneous mixture, something that you can't visibly see a difference, you have a solution, okay? Examples of this would be just like tea or lemonade or Kool-Aid or air. Air is a mixture. The air that you're breathing is a mixture of gases that are not chemically bonded to each other. Nitrogen gas floats around separately than oxygen gas does, okay? But it's a mixture. Right? So tea, Kool-Aid, air, those are all good examples of solutions. So that means then that with these then, homogeneous and heterogeneous solutions, all of these things can be separated. They can be separated. They can be separated by some physical process. These mixtures, heterogeneous and homogeneous, can be separated by some physical process. Okay. All right. So ways to separate a mixture. Now there are multiple ways, but we're just going to really focus on 3 this week. Okay. The first way is distillation. Distillation will separate liquids based on the different boiling points involved. It separates liquids based on the different boiling points involved. And if you've ever heard of like a still, like a whiskey still, or like, you know, back in the day when they used to run moonshine, or like breweries now have stills set up in them. They're just, it's distillation, that's what they're using. They are taking advantage of the fact that alcohol and like water will boil at different temperatures. They collect the alcohol off of it and then process it and create whatever kind of liquor they're going to sell. Another kind of separation of a mixture would be filtration. Filtration is just where you're separating solid from liquid, separating solid from liquid. Okay. And then finally, chromatography separates liquids or gases based on their ability to dissolve on a medium. Separates liquids or gases based on their ability to dissolve on a medium. Okay. Now, what we did today is we did this type of separation. We did one of these types of separation today. Okay, we did one of these types of separation today. With the paper towels and the colored water, did we do distillation, filtration, or chromatography, do you think? Which one is represented with the paper towel sucking up the liquid? Going to be chromatography. Okay, so let's talk about why. All right, so here's what we're going to do now. I'm going to get this back to I'm going to stop sharing the screen here. Is everybody good, or are you still writing? Going once, going twice. All right, I'm going to take that off. I'm going to stop sharing that part. So hopefully, let's see. go back to this. Okay. So now, at this point, I'm going to call you up a few at a time, and we're going to take a look at these, okay? So let's see here. So bear with me just a second. So if any of you are going to watch this at home, this is what we're looking at. Okay, so we've got these three things, and I don't know if you can see the paper towels there, but there is some separation going on, okay? So that's what we're going to talk about here in just a second. Okay. All right. So tell me, if you're looking at this, first of all, chromatography is one way to separate a mixture. If you're talking about chromatography, you're separating liquids based on their ability to dissolve within a medium. So what's the medium here? What's the thing through which it's traveling? The paper towel, very good. The paper towel, that's the thing that the water is traveling through. Now, if the water is carrying with it particles of color, and so as the water travels up through the paper towel, all of a sudden it's going to start to separate into whatever particles are there. If you take Chem 2 next year, you will be doing an experiment like this, but you'll have to do a little bit of math with it because I'm going to ask you to calculate its rate of flow, and you've got to classify like which color had the best rate of flow, which one do you think was the biggest particles, and why do you think that? But if particle size has any indication of like how fast it's going to travel, it does make you wonder if like blue particles are smaller than like purple particles because they get to the end of the rope faster. Are they just smaller? Do they just travel faster? Okay, but chromatography is a way to separate a mixture just based on the fact that it can dissolve in a medium of some kind. It can travel through a medium, okay? So you guys are going to come up here a few at a time here in just a second. I'm going to ask you some questions about this. But I'm going to go ahead and stop recording now before you come up.